in this video we will discuss the problem set matrix zeros. The problem says that we'll be given a 2D matrix of n cross m size, and the task is to modify the matrix such that if the mat of ij is equal to 0, so if the ith row and the jth column element is equal to 0, then we have to make sure that all the elements of the ith row are set to 0 and all the elements of the jth column are also set to 0. We have to do this in constant space complexity. So let's discuss this using a test case here. Suppose that we have been given the test case, that is 0 1 2 0. Then after that we have been given 3 4 5 2 and then 1 3 1 5. This is the matrix that we have. So you can see here that the element in the 0th row and the 0th column is equal to 0. So we'll mark all the elements in the 0th row as 0 and all the elements in the 0th column as 0 as well. So what will happen because of this? You can see that all the elements in the 0th row will be marked as 0 and all the elements in the 0th column will also be marked as 0 here. Then after this, what will happen next? The next element that we find out that is 0 is this particular element. So now all the elements in this row will be marked as 0 and all the elements in this column will be marked as 0. So what will happen is you can say that you will have 0 and 0 here. Then after this, is there any other element that is 0? No. So you can see that we'll have 4 5, then we have 3 1. So this is the output here. Let's see if this is the actual output expected here or not. So you can see here that we have got 4 5 3 1 in between, and rest of the other peripheral elements are equal to 0 here. So that is what we have here. So this is what is expected from us, that if the element in the ith row and the jth column, if it is equal to 0, then we have to make all the elements of the ith row equal to 0 and we have to make all the elements of the jth column equal to 0. This is what our task is all about. Now how can we solve this? Let's discuss the basic brute force approach first. So what we can do is, in a brute force approach, we can take row and column arrays to identify that which row and which column we need to mark as 0. So initially what we'll do is, we'll initially take all the rows, we'll take a row array. So basically we'll take 1D arrays. There will be a row array which will be equal to the size of the number of rows, and there will be a column array that we have which will be equal to the number of columns that we have in this particular given array. Now I have represented them horizontally and vertically so that we can understand things better. Now what will happen is, whenever I'll be at a particular element, let's say if I'm at a mat of ij which is equal to 0, if I'm at an element which is equal to 0, then what I need to do is I need to mark the row of I as true, that I need to mark all the elements of the ith row as 0, and I'll mark the column of j as true as well, that I need to mark all the elements in the jth column as 0 later on. So what will happen here? If you will see, initially when I'll be iterating, so let's just keep this here. Now initially when I'll be iterating, so I am at this particular element 0 comma 0. Now this element is 0 itself. So then I'll mark the row 0 as 0 and the column 0, like I'll mark the row 0 as true and I'll mark the column 0 as true as well. So basically we will have the values true and true here. After this, the next element that we find out that is 0 is basically this particular element. So what we will do is, we'll mark this particular row as true and we'll mark this particular column as true as well. So this column will be marked as true as well. Okay, so this is where we mark it as true. Now you can see that there is no other element that we can mark as true. So what we did was, we iterated throughout the matrix, and wherever the element was equal to 0, wherever mat of ij was 0, we'll mark the row of I as true and we'll mark the column of j as true. That later on we'll mark all the ith row elements as 0 and we'll mark all the jth column elements as 0. Now after this we'll iterate. So we'll iterate and check for every element, for like if like we'll iterate for every element later on, and what we will check is that if there is any element for whom the row is either true or the column is either true, then we'll mark it as 0. So you can see here, when initially we'll be at this element itself is 0 and the row and column both are true, so this will be 0 only. Then after this, when I'll be at the next element, that is 1, I can find out here that the row is true, so I need to mark this element as 0 here. So I'll mark it as 0. And after that, I'll be at this element 2 here. Now for this element, the column is false, but the row is true. So I'll mark this as 0 also. Because if any of them is true, then I need to mark the element as 0. If either the row is true or the column is true, then this means that I need to mark that element as 0. Now after that, when I come across this element, row and column both are true. So I'll mark this, like this will be marked as 0. Already it was 0. Now after this, what will happen? Next up, when we go down, so this particular element, for this particular element, the row is false, but the column is true. So we'll mark this as what? We'll mark this as 0 here. Now after this, 4 will remain as it is. 5 will remain as it is, because for 5, row and column both are false. Then for 2, the row is false, but the column is true. So we'll mark this as what? We'll mark this as 0 here. Okay, because the column was true, so we'll mark this as 0. Then after this, what will happen is, next up, for this element that is 1, the column is true So we'll mark this as 0 here. And then after this, for 3 and 1, the row and column both are false. But with respect to 5, the row is false, but the column is true. So we need to mark this guy as what? As 0. So we'll mark this particular element as 0 here because the column was true. Now you can see that we have got the expected matrix here. But the issue is that we are using extra space in this approach. So what is the time complexity here? If you will see the time complexity, so basically we are iterating throughout the matrix overall. So this will take n cross m time. But in terms of space complexity, we have order of n space complexity for the row array and order of m space complexity for the column array. So you can see here that by taking this extra row and the extra column, I'll be able to identify, I'll be able to mark that which rows and which columns later on need to be marked as 0. Whichever are true, they will be marked as 0 later on. Let's have a look at the code here as well. If you will see here, so what we will do is we'll take the length of the row and the column. Then after that, initially everything will be marked as false in the row and column, and we'll iterate in the matrix. If the I comma jth element of the matrix is equal to 0, then we'll mark the ith row as true and the jth column as true, because later on we want to mark all the elements of the ith row as 0 and the jth column as 0 as well. Now after we have updated the row and the column array using the if condition, then after that we'll iterate throughout the matrix, and if I am at a particular ith row and jth column and either the row I is true or the column j is true, so in that case I will mark that element as 0, because either if that ith row is true or the jth column is true, this indicates that one of the elements in that ith row or the jth column was 0. So I need to mark all the elements as 0. So we'll mark the mat of ij as 0 here. Now you can see that this will take n into m time complexity and the space complexity will be n plus m. Can we optimize this a bit more? So let us discuss the optimal approach for solving this problem. Now what we can do is, earlier we were using external column array here like this and external row array like this here to store the status for the rows. But now what we will try to do is, instead of using external row array, our very first row is going to store the status like this for the rows. Okay, and we will try to store the column status in the first column like this. Now you will say that how can we do this? Because if we will try to do this, what will happen is, understand one thing, that if the internal row is indicating the status for all the rows, the very first starting row is indicating the status for all the rows, and this column is going to indicate the status for all the columns, the issue is that there is an overlap at this place, because this place is indicating the status for the 0th row as well as the 0th column. Now I can't do that because I can't overlap the status for the 0th row and the 0th column at the same place. So I need to adjust this. So I cannot allow overlap. So that is why what we will do is, we'll say that we will use this column, but for because there will be an overlap, because if I'll use my 0 comma 0 element, so it will overlap for the 0th row as well as the 0th column. I don't want to do that. So for resolving that conflict, what we can do is, we can take one variable, that is column 1. Let's say we can name it as column 1, let's say starting column, and initially we can mark it as 1. It will tell me the status about the starting column, or you can say 0th column. So let's take it as column 0 here. It will tell me the status about the 0th column, that is column 0 here. Okay, initially we have marked this as 1 because we are trying to indicate that this element is initially 1. Now after this, what will happen is, we'll iterate throughout the matrix, and wherever we find that the element is 0, we'll mark that in the corresponding row and the column. Now if you see here, what will happen is, initially I'll be at 1, it is fine, then I'll be at 2, it is fine, 3 is fine, 4 is fine, 5 is also fine. But when I come across this element 0 here, so what can I say? When I come across this particular element 0 here, then I can say that because of this element 0, I have to, like, this element 0 is standing where? This element 0 is standing in the first row and the first column. So I have to make the elements of the first row and first column as 0 here. So what I'll do is, I'll mark this particular guy as 0 here, and I'll mark this particular guy as 0 as well. Now after that, what will happen later on when I'll iterate? So I'll find that this particular element is also 0. This particular element is also 0. So which element is this element indicating? So this particular element is basically in which row? In the second row and the 0th column. It is there in the 0th column. Understand that it is at 2 comma 0 position. So second row is already 0. You can see second row element is already 0 because it is in the second row only, and the column 0 should also be made as 0. So we'll update the column 0 as 0 here as well, because this particular 0 is lying in the 0th column. And after this, you will see here that we have identified one more element here, that is this particular 0. Now what will happen is, the last row and the last column will be marked as 0. So this particular element will be marked as 0, and this particular element will also be marked as 0 here. So this is the status of the Great so far. Now let me write this so that you can understand it better. So you will see here that the elements are looking like what? The elements are basically 1, then you have got 0, okay, then you have got 3 here, okay, then you have got 0 here, then after that you have got, 0 here as well, then you have got 0 here as well, then you have got 7 here, then you have got 8 here, okay, then you have got what? Then you have got the element 0 here, then you have got what? 10 here, you have got 11 here, you have got 12 here, okay, then you have got 0 here after updating the matrix, then you have got 14 here, 15 here, and 0 here. Now notice one thing, as I already told you, column 1 was also equal to column 0 was also equal to 0. So this is the status for the columns here, and this is the status for the rows as of now. Now what will happen after this? If you will see here, now once we have reached this particular state, so our row and the columns, they are ready with their representations. Now we need to do what? Firstly, we will iterate in this internal part. So we'll start iterating from the index 1 comma 1, and we'll iterate all the parts till the last row and the last column, and we'll update the status of those elements here. Okay, so what is going to happen in that case? Initially, if you will see here, so when I'll be at this element 0, so when I'll be at this particular place, so the row and the column both are 0, because this is also 0, this is also 0, so it will be marked as 0, but it is already 0, so it will not update here. Then after this, you will see here that when I'll be at this element 7, so for this particular element 7, the row is basically like this particular place is 0. So that is why we'll mark this as 0 here. So we need to do what? We need to mark this particular guy as 0. Then 8 will also be marked as 0, because you can see that above also, and column and row both are 0 for it. Then after that, for 10 also, this will be marked as 0. Then after that, you will see that 11 will also be marked as 0, because this particular row is completely 0. So we need to mark it as 0. 12 will also be marked as 0, because you can see that the row and column both are 0. 14 will also be marked as 0. Okay, then after that, what will happen? 15 will also be marked as 0, because for it the row is basically 0. Okay, and then this last element is 0 itself, so no worries about it. Now if you will see here, what is the status of this matrix? Let's draw it further. So after this, you can see here that what I did was, initially I iterated throughout the matrix, and if the mat of ij, as I said, initially we iterated throughout the matrix, and if the mat of ij was equal to 0, then we updated the status in the mat of 0th row, and the 0th row and this column here, we updated the status like this, and then we updated the status for the 0th row as well. So we updated the status accordingly. Now once we are done with this part, so you can identify one thing very clearly here, that once this part is done, so after this internal part from the index 1 till the end, it is now processed. So how does the matrix look like? Now the matrix is basically nothing but, you can say, you are having 1, then you are having 0, then you are having 3, then you are having 0, okay, then you are having 0, 0, 0. All these elements are 0 only, so let's write them as 0. Now 0, this is also 0, this is also 0, this is also 0, and this is also 0, this is also 0, this is also 0, and this is also 0 here. Forgive my writing here. Now you can identify that this is the row that you have, and this is the column. So column 0 is equal to 0, and this is the column. Now so far we have done the processing starting from the index 1 comma 1 and till the last element of the matrix here, that is, let's say, n minus 1 comma m minus 1 here. We have done the processing for all those internal elements. Now we need to do the processing for the for this particular 0th row, based on the 0th row and the 0th column. Now how will I do the processing? Now understand one thing very clearly, that it is also very important that you have to decide the order in which you are going to do the processing here. Why? Because suppose now, if you start processing according to the 0th column, what will happen? If you see here, now you identify that 0th column is equal to 0, so you will say that all the elements in the 0th column will become 0. If you do that, what will happen? If you do that, then you will say that because of this, all the elements in the 0th row will become equal to 0, because if the column 0 is 0, if firstly you will process the column, there will be an issue here. Why? Because column 0 is responsible for all the elements in the 0th column. So if you see column 0 is 0, now you will process all the elements of the column 0 and mark them as 0. So you have marked these elements as 0. Okay, then if you do this, if you have processed this particular place, then after this the remaining elements are 0, 3, 0 like this, and 0, 0, 0, 0, 0, 0, and 0, 0, 0 here. Now what will happen after this is, now you will say that you will process this particular row. Now you will say that this particular row 0 is 0. If the row 0 is 0, then all the elements of the row 0 will be marked as 0. And now you will tell me that all the elements of the row 0 will be marked as 0. So because of this, what will happen is all the elements of the matrix will become equal to 0. And this is wrong. Why this is wrong? Because you should not process the column 0 first. After you have processed the internal elements, you should not start processing the 0th column. Because if you process the 0th column, then this is going to be wrong. Because if you process the 0th column, then what has happened? Because you have processed the 0th column, so you have made this particular element as 0. Now the moment you make this particular element as 0, that is this element that was 1, you have made it as 0. So later on, when I'll process this particular row as well, so everybody in this row will be marked as 0, and because of that, the whole matrix will be 0. But that is wrong. Instead of that, what you should have done is you should have processed the row first of all. Like you should have checked the 0th row first of all. You should have checked the 0th row first of all. So when you check the 0th row first of all, so you identify that the element of this 0th row, it is basically what? It is 1. So if it is 1, if the element of the 0th row is basically 1, then when you will process this particular row, so nothing will change, because if this element is 1, it indicates that the 0th row was equal to 1. So if the element of the 0th row is equal to 1, this means that all the elements will remain as it is, and you will not make any elements as 0 by traversing. So that is why what will happen is, in this case, if you process the row first, so this element is 1, so because of that, the 3 will still remain. Because if this element is 1, if the element of the 0th row is 1, this indicates that the 0th row elements need to be preserved. So that is why this will be 1 only, this will be 0, this will be 3, this will be 0, like this. Now after that, once you have processed the row, then you will process the 0th column. Now the moment you come to process the 0th column, so since the 0th column is equal to 0, so you'll mark all the elements in the 0th column as 0. So what will happen is all the elements here will be marked as 0 here. So what will happen is this will become 0, this will become 0, this will become 0, and this will become 0. And you know already that all the internal elements were already equal to 0. So the final expected answer is basically 0, 0, 3, 0, and then rest of them are 0. But if you would have processed the column first, then things will go wrong. Because the moment you process the column first, then you are in trouble. If you process the column 0 first, what is the issue? Because see, initially we have processed the internal elements starting from index 1 comma 1 till the last row, last column. We have processed this part easily. But the thing is that we have to also process the 0th row and the 0th column. If I process the 0th column first, then I'll be in trouble. Because if I see the 0th column, it is equal to 0. So I'll mark all the elements as 0 here. I'll mark all these elements as 0. The moment I mark all these elements as 0, then later on when I'll traverse for the starting row, for the 0th row, then since I'll find that this element will become 0, so I'll mark all the elements as in the 0th row as 0 as well. And that is going to be wrong, because this element 3 was dependent on the row. This element 3, it does not have anything, it does not have any relationship with the 0th column. The element 3, this element belongs to which row and which column? It belongs to the 0th row and the second column. It belongs to the 0th row and the second column. So that is why you can identify one thing, that since it belongs to the 0th row it belongs to the 0th row and the second column, so second column has this element 3, you can see here, and the 0th row has the element 1. So this element 3 should be there. This element 3 should be there. It should never become 0. So that is why if you process the 0th column first, then you're making all the elements of the 0th column as 0, and because of that, this element will become 0. This element becomes 0, and then after that you will process the row. So you will make all the elements in this 0th row as 0 as well, and that is wrong. So that is why what you need to do is you need to process the row first of all. So process the row first of all. Look at the row. If this element is 1, then the status of all the other elements in this row will be preserved. So that is why this element 3 would be preserved, because it is belonging to the 0th row and the second column, and the 0th row was equal to 1 initially. So this meant if the 0th row was equal to 1, so this meant that the element should sustain, the element of this 0th row should be available. Okay, and then after that you will process the column. When you process the column, so you will process it like this, and everybody in this 0th column will become 0. So now later on, after preserving this 3, then this starting guy can become 0. I don't have any issues, but I will not process the column first. Okay, firstly I'll process the row, firstly I'll process the 0th row, and then later on I'll process the 0th column here. I hope that you have understood this very clearly. Now let's have a look at the code here. So after this, what you will do is, you can see here that column 0 will be initially marked as 1, and then what you will do is you'll iterate in this code, and you will iterate for the rows and the columns. If the mat of ij is equal to 0, then you need to do what? You need to update mat of i0 as 0. So you need to mark the ith row, and after that you also need to mark the jth column also. Now there are two kind of jth column that you can have. Suppose if the j value is equal to 0, so this means that you want to, like, the element at the 0th column is equal to 0, so you should update c0 as 0 in that case. So that is what we are doing. If the j is equal to 0, then update the 0th column equal to 0, because if the j is equal to 0, so the element of the 0th column is 0, so c0 should become equal to 0. Otherwise, if it is any other column, so then update it accordingly. So as I said, if we have a matrix here, if we have a matrix like this here, and if this particular element is equal to 0, then update the column 0 as 0 as well. Or if this element was 0, or if this element was 0, this element, then update the column 0 as 0. But otherwise, suppose that this element was 0, then you have to update this particular place as 0. Okay, so that is what we are highlighting here. This will indicate mat of 0j here. Okay, if this was, let's say, mat of ij, then mat of 0j will be updated as 0 here. I hope you have understood this. Now after this is done, after we have traversed the matrix and we have updated the status in the 0th row and the 0th column, then we will traverse for the we'll traverse for the internal elements, that is from 1 comma 1 till the end of the matrix, and we will check if the mat of I0 is 0, or if the mat of 0j is 0. So if this boundary, in this boundary anything is 0, or if this in this boundary, column boundary, anything is 0, then update the element at the mat of ij as 0 here. Okay, same as we were doing in the brute force code. Then after this, as I said, you will also check once that is done. So once you have done, so see, if you have a matrix that is present here, so once you have done the processing, so let's write this matrix here first of all. Suppose that you had this particular matrix here, and you know that this particular row is indicating, and this particular column is indicating the data here. So you have done what? Using this particular row and column, you have updated all the internal things. So you have updated the data everywhere in this particular segment here correctly. You have updated everything in this particular segment here. Now it's your time to update the data in this row and this particular column as well. So what will you do first? You will update the data according to the row. So you'll check for the row. You'll check for the row, because suppose if column 0 was equal to 0 and there was an element existing here, but you will make it a 0 and you'll make everything 0 in this particular row. That is something which you should not do. Column 0 should not define what should happen to the elements of the row 0. So firstly process the elements of the row 0. If the row 0 is 0, then only make the elements of the row 0 as 0. If the row 0 is already 0, if the row 0 is already 0, if it is already 0, then only make all the elements of the 0th row as 0. Otherwise don't, because if the row 0, let's say it is having the element 7 here, so then all the other elements that are existing in the row 0, they should be prevailed, and then later on you will be processing for the column. So process for the 0th column here. Don't allow the 0th column to influence your 0th row. Don't allow the 0th column influence the result of your 0th row. So first of all process the 0th row, and then after that process the 0th column here. Okay, so firstly process the elements of the 0th, process the elements of the 0th row. So if the 0th row, firstly process the elements of the 0th row. So if the 0th row is basically having the element as 0, then update the elements as 0. Otherwise don't, preserve them otherwise. And then after that you will iterate and change the element of the 0th column based on the value of the 0th column. If the 0th column value is 0, then update all the elements of the then update all the elements of the 0th, then update all the elements of the 0th column as 0 here. So you can see here, this is what we are doing. Now this will take how much time? In terms of time complexity, my code will be order of n into m, because we'll be iterating throughout the matrix here. So this is the time taken here. And are we taking any extra space? No. So the space complexity will be order of 1 here. I hope you have understood this clearly, and let's now submit the code as well. So let's submit this code and it should get accepted here. So you can clearly see that my code was able to pass all the test cases. I hope you have understood this problem clearly. Thank you for watching this video.